Hi, my name's Landon, as you can see there. I'm a senior monkey patcher from Testable. So, you can find me on Twitter, LinkedIn, Mastodon, all the places. So the name of my talk is, I always forget, it's forecasting the future. We're going to look at using Ruby to do machine learning, native Ruby, no PyCall. If you know what that is, you're calling into like Python libraries and using some of that. But this whole thing started with a question I had several years ago, and that question was, why aren't people doing machine learning in native Ruby? And this question plagued me for some time. If you're familiar with this space, you know that a lot of people use Python or C++ or R, and those are some of the common tools, but I didn't really see a reason why we couldn't use it in Ruby. So that is the goal of this talk, is to show you a machine learning project built in native Ruby so that all of you can go out and build your own machine learning projects. So, but before we get into that, there are two things I wanted to discuss with you. One is tools, and the other thing is libraries. So for tools, I end up using something called Jupyter Notebook. And what that is it's basically your IDE, essentially, for your data science projects. You can write code in it, and a lot of times in the Python world, they use Jupyter Notebooks with Python. And this one has like an iruby kernel, which allows you to type Ruby code in the Jupyter Notebooks. So this is a Jupyter Notebook. As you can see, I put 1 + 1 into it, that's Ruby. You execute the code, and it comes out with 2. I wrote a function or a method called hello, which just prints hello, and when you execute it, hello prints to the screen. So all of the work that we'll be doing today, building out the model, machine learning model, and executing code will all happen in here. This is basically our Visual Studio or equivalent. So there's a lot of really cool things you can do with it. So this is just an example. So there's a lot of libraries that you can utilize in Ruby and Python. Like here, this is the only part where I'm using any Python code. But I'm calling a library called Seaborn, which is a data visualization library. And I'm printing some data points onto a graph. So you get a lot of really cool visualizations if you're working on a data science project. So you can like pass this Jupyter Notebook around to like an exec at your company or a peer, and they can run all the code that you did in this notebook. Next, we're going to talk about libraries. So I use 3 libraries to do this project. I use Numo, Inarray, I use Daru, and I use Rumali. So Numo ND-array, what that is it's an n-dimensional array library. So when you're building your model, you ended up putting that in this data structure and passing it to your model, and so it'll build your model. And Daru is a data frame. So the data frame is you can imagine it like an Excel spreadsheet. It's a 2-dimensional array with your rows of data and your columns. It's more performant, so you can kind of run through it, and we'll get to some examples of that. And then Rumali is a Ruby, it's a machine learning gem for Ruby, and that's gonna be where you're gonna have your models that you can import. So I'm not sure if this one has like neural nets, but all the different machine learning models, that library will have in it. So first, we have to start off with a problem, and the problem that we want to solve is predicting the weather. But for this example, what I wanted to do was I wanted to predict the max temperature. And so that's kind of what I went for. So now that we have our problem underway, we need to collect some data. So for this problem, what I did was I went to the National Centers for Environmental Information. They have some lovely data sets on that website. And I downloaded a data set for, it's the weather data for the Atlanta airport. It's historical data and I got about 63 years worth of historical data going back from, I think, 1960 to, or I can't do math, but to current time. And so this is the data that we're going to use to build our machine learning model to hopefully predict the weather for a given day in Atlanta. So now that we have our data, we've downloaded our data, we're going to get into a little bit of data preparation. So it turns out when you're building a machine learning model, you can't just go to some site, download a bunch of data, throw it into the model, and out pops answers. It turns out all the data, most of the data that you're going to get from the outside world, even if you're scraping Google or getting refined data sets, that data set's going to have a few problems in it. So, but we'll get to that. So here is the CSV for the data set that I had. Right here, I'm using Daro. So I'm importing that CSV into the Daro data frame, and then I'm duplicating the data because I want to have like one set of data that's my original data, and then one set of data that I can like modify it. So I'm going to do things like drop columns or drop rows in that data to kind of get the data and finagle it into a format I can use to put into my machine learning model. So, and over here, these are all the different like columns that are in the data set. So along with the data set, when I downloaded it, I got a PDF from that site, and the PDF had a list of all the different parameters or variables or columns on that data set and like the names. So as you can see, PRCP isn't really a distinguishable thing to us, or SNWD is not really distinguishable. So it has all the definitions about what those columns are. So PRCP is the precipitation, snow is snowfall, SNWD is snow depth, Tmax is the maximum temperature, and these are all for a given day, and Tmin is the minimum temperature for a particular day. So there are more columns in that data set other than these, but the document said, hey, these are the 5 core values that we've designated. And I think that these core values have something to do with predicting the maximum temperature. So if you think about it, yesterday, let's say it was 60 degrees. What's tomorrow going to be, if you had to guess? Probably something close to 60 degrees, either warmer or colder. So it seems to be somewhat predictive. So I thought I'd use all these core values to kind of build my machine learning model to simplify it as we kind of go through this example versus like the 48 that are in the data set. So what I did was I'm creating a new data frame here. All I'm taking is the precipitation, this snowfall, and all those 5 core values, and I'm putting that into my data frame, and also the date that we read those values in. So that's January 1st, 1960. The precipitation was 0.16. And that's like the reading for that day. So this is the data set we're going to use to build our model. And so now that we have like the core data we're using, we're going to have to clean up the data. So again, we're going to have to go through, we're going to have to deal with any missing values in the data set, because how are you going to build a model with a bunch of nils in it? Like, that doesn't make sense. It doesn't know how to compute those with the other values. You're going to have some outliers. So occasionally, you know, if like this week the average temperature was like 60 and the low was like, let's say it was 40 and the high was like 70. Let's say we had one day this week where it was like 120 degrees, right? Like, we don't want to put that, and we don't want to use that to build our model, because that's going to throw our whole model off. So we have to deal with outliers. We have to deal with malformed data. Let's say something weird happened where the computer took a reading of the sensor took a reading of the temperature for a given day, and it got like some weird value that was like broken, or it gave us a nil, or it put characters in it, or whatever happened. Maybe someone scraped the wrong data. We're gonna have malformed data that we need to figure out how to handle that. And then occasionally we're gonna have duplicate data. So maybe one day, one row in the data set is like today, and then the next row is tomorrow, and then the next row is that same day. Like, we want to treat the duplicate data so we're not double counting those when we build our model, also throwing our model off. This is like a little of the work that I did cleaning up the data. So I just wrote a little method that just checked, hey, for each given row, is there a column that contains nil? If so, let's like get rid of all those columns, like all those rows that have like a nil column. So I chose to just drop the column, I chose to just drop the row if it had a nil column. That may not be the best way if you're trying to do this for like a production machine learning model, because you want to keep some of the data. Like just because you don't have the average snowfall, you still might have the the max temperature in that row. You might not want to throw the whole thing away. So there are techniques that data scientists can use to deal with those, but like I just chose to drop them. Some of those techniques include, instead of like dropping the whole row, I might just take an average of, say, all the values in the data set and just impute that average into that nil value. And that might be a better way to handle it. But again, that depends on the shape of your data. This is a new slide I added. So this is sort of like an advanced topic. It's called feature engineering. So we're going to add one more data column to our data set. And that data column is going to be, well, first I had a question. So if for a given day we're trying to predict the max temperature, is there a problem with like the columns that I have here? So it's like, let's say we have today's date and we have all these values. It's January 1st, 1960, and tomorrow we want to predict the max temperature, right? Right here, 37. One of the problems that we're going to have is we don't want to use 37 to predict 37, because 37 is the max temperature for today. We don't want to use that to predict the max temperature for today. We want to use the previous day's max temperature to predict tomorrow's max temperature. But we don't have that here. And so one of the things I did was like, I'm going to create an extra value, which is the max temperature for the previous day. So I wrote a method that basically went through, if you see in rows, let's see. If you see in row, the second row, which is number 1, we have the Tmax, which is 39. I created a new target max temperature in the right column, which is also has 39 for the first row. And basically, I used the previous max temperature and I just put it like for the next day. And I like shifted all the max temperatures like down, basically. So that we're using the previous max temperature to predict tomorrow's max temperature. So that was like one thing I had to do to like kind of clean and finesse the data a little bit. So that was a lot of work, and it turns out this is, as glamorous as machine learning is, this is a lot of what you're going to have to spend your time doing, is like going out, hunting down data sets, getting those data sets, cleaning them up, finding out how to deal with the missing values, adding new columns that you want to add because maybe they're helpful in building a model. And that's like a lot of work. So there's actually a rule for that. It's the 80-20 rule. So you're going to spend about 80% of your time as a machine learning engineer, which I am not. I'm a software consultant. But if you became a machine learning engineer, you're going to spend 80% of your time wrangling all that data to get it into some format to be used by the model. And you're only going to spend about 20% of your time building the model, which is pretty quick and easy, as we'll see, and tuning the model for your specific use case. So next, we're going to get into that 20%, which is training the model. So for training, the way we do that is we take our full data set and we got to split it into 2 parts. We have our training set, which is the set where we're going to put it into the model to build it. Basically, the way it's going to kind of work is you put in the data and like the computer will basically like guess what the value is that for the maximum temperature that day, and then it'll be able to, since you're giving it the x value or the value, like it'll be able to predict like what it is, like it already knows. So it's going to fine tune the model based on those values. Sorry, I'm going to get to that in a later slide. but this is me splitting the data. So I'm taking 80% of the data, the first part of the data, and I'm putting it into the training set. Then we're going to put the other 20% in the testing set, which is what we're going to use to like validate whether it's correct. And so the model that I used to build this out was linear regression. So linear regression is an attempt to model the relationship between two variables by fitting a linear equation to the observed data. So does anybody know what this formula is? You can shout it out or raise your hand or whatever. Yeah, so it's a formula for a line. So it's like y equals mx plus b. And so it can also be written this way. And this is kind of the way I like to see it written, because it's helpful to think about it like intuitively in terms of the data that we have. So going back to the training data example, so you have all these columns that you're using to predict something. If we remember from our algebra class, that's kind of what we did with the formula, y equals mx plus b, or y would be sometimes f of x. So your input values are the x. So that T min, that minimum temperature, the snowfall, it's going to go into the x value, and then out is going to pop a y value, mx plus b, and whatever pops out of there is like our answer. That's like what we're trying to predict. So this is an example of like maybe how our data is maybe spread out. And what you want to do is you want to do like a best fit line, or linear regression line, which will kind of map a path to kind of minimize the distance between all the different points. And that's basically what like linear regression is. It's not necessarily the best way. Like there's other ways you can kind of map this data. As you can imagine, you could draw a line between all these points to kind of be like, hey, I want to hit all the different points. But this is like one way to do it. So if we have like a value like that gets inputted, like these, it can see the difference between like those values and the line. So this is like basically the magic of building a model. So I'm basically using Rumali here, and I'm inputting the linear regression model. I'm passing in the training values for x and the y training values, and it's building that model. It's trying to take all the data points, if you imagine, on that graph, and it's all it's doing is it's saying, how can I draw a line that closely matches, just a straight line that closely matches all those data points? And it's going to keep moving the line until it gets the line where the distance between all those points is like minimized. So that's it. That's really all you need to do to like build your machine learning model. And then with that, you can make predictions. So here we have the test data, which after we build the model, after we train it on the training data, we separated some of the data later, and we're putting it back in to kind of test like, hey, here's a value that you don't know what the answer is for. What if we pass those in? What are you going to predict for those? And then we get all these values for those training values that we passed in, the testing values that we passed in, and then we can match those to see if like that was the actual output for that given day. And then the distance between those two values would be like how far we were from our prediction. And so we could like evaluate how well our model was doing. So these are kind of the steps. And so we set up our problem, we collected the data, we did data preparation, we trained the model, and we made our predictions. So thank you. I do have a gift for you though. Yeah. So if you go to this URL, this is like the whole repo that I use to kind of build the machine learning model. And this kind of outlines sort of the steps, each of the steps that it takes to kind of build the models. And you can follow this instead of like, maybe using the linear regression model, you can use a different model, maybe like a neural net if Rumali has it, or you can use There's another model called K nearest neighbor. And you can kind of see like, hey, some of the models perform slightly better, some of the models perform slightly worse. Spoiler alert, linear regression is probably not the best way to predict the weather. Like, you're not going to be able to draw a line between all the weather points that is going to make any sort of sense. And also, here's a nice newsletter you can subscribe to for test level if you want to find out more information. I'll put this back on if anybody wants to see it. So I gave this talk once before. I updated it, I updated the repo a little bit, so now it has a Docker container that you can just like run it if you want to like kind of reproduce the project and play with it. It is fairly big because I didn't build it from scratch. It's like several gigs. I'm sorry. Maybe I'll clean it up. But I think it's pretty good. So that's all I got. Any questions? Yes, I expect as much.
How many rows were in the data set?
Oh yeah, I skipped over that. So there were, I skipped over it. We'll get there, we'll get there. Oh, it's like 20,000. I think it's 23,000. I have that slide in there somewhere. It might be in the notes. It's like 23,000.
So I'm not a data scientist. So
Okay.
like, what's sort of like hey, this is a good, and then like the threshold of like, we can test this amount of data, this is like a good marker of like, what should we like decide on data.
Yeah, that's a good question. So it turns out, I'm not a data scientist either. I just took a bunch of classes. But it turns out the amount of data that you are going to need, like, it honestly depends a little bit on like the model or the algorithm that you're using. So I don't know, like for linear regression, I'm pretty sure I have enough here, but I might Google like, okay, what's the minimum data samples that I should use for linear regression? Or what's the minimum number of data points I should use for like K nearest mean or for like my neural net? I think it's going to depend on like the algorithm, but there are problems around like maximums. Like if you give certain models too much data, it's going to take like exponentially long to run and to complete. Like if you run my project, it'll probably finish in like 5 minutes, but that's not even the machine learning part. That's like some bad code I wrote that like takes too long to calculate. I forgot what it was, but it had nothing to do with the model. It just had to do with me being a bad programmer. But but like, you know, like I imagine like ChatGPT's model, like I don't know how long that took to train. And if it's not on a really fast computer, you know, it could take, I don't know, days, months, years, like for the maximum. But I hope that answered your question.
Well, I actually have a follow-up.
Yeah, go ahead.
So how did you decide, okay, 80% is what I'm going to train it on, and 20% is what I'm going to test?
It's kind of a rule of thumb. So depending on how much data you have, like typically people will use like 70-30 or 80-20. That's typically like the standard. You want to train the model on more of the data than you're testing it on, because everything that you're using to test isn't being used to train, if that makes sense. So I used just 80% just because I wanted more training data. I wanted the model to see more data points, and you know, I guess I didn't really care that much about testing, which I left off a whole slew of stuff that could be tested in terms of like scoring the model to see like, well, how accurate it is. Is it 90% accurate? Is it 20% accurate? Like, you know, is it 50% accurate? Oh, yep, back there.
So you said you were sad for a while, no one was using Ruby for this kind of stuff. So in your research, did you discover why? Is it just community stuff?
Yeah. Yeah.
Landon, if you could repeat just for folks who might watch the recording later, maybe repeat the question
definitely.
before you answer.
So the question was like, why weren't people using Ruby to do, machine learning, and why were people using like Python and things like that instead? So the question, the answer that I came up with after talking with other people is 2 reasons. So one of it is because of like the libraries. So like Python had like a head start. So like a lot of people built a lot of like libraries in it. There's like pandas and I think it's like NumPy, which are some of the core libraries people use. And that stuff hadn't been built out in Ruby yet, or people weren't using it as much. So the libraries, and I think the other part is like the community. Like a lot of the data scientists just sort of tended to go towards Python. And so like that community kind of got more vibrant, and you know, the Ruby community is strong, but like not a ton of people had been kind of in this data science space. And I don't know, I think it's for good reason. Like there's a lot of like math involved and formulas, and it's like depending on your path, like if you went more of the mathematical science route versus the engineering route, you have different exposure to like different things. So, you know. I think I have 4 minutes if there's any other questions. Yeah, I don't know who's first. Fight it out. Yeah. My model's probably 20% accurate. We can check afterwards.
So if you were to use it for the prediction, like to see what the temperature would be tomorrow, is the prediction based on previous years for June 9th, or is it more of like the average of what the variation was between previous day and current temperature? Like how does that actually work to predict?
So you're asking like how, like what subset of data is being used to predict the future temperatures? Yeah, so when I trained it, the way I split it was I took the first 80% of the values to train the model with, and then I took the last 20% to kind of like test, because those were like the future values.
So I probably still know how to answer how I asked this well. I'm just trying to think about like what is actually being used. So if you want to predict a specific day, you know, tomorrow, June 9th, like what is it looking at? Like would it look at you know 2022, 2021, what values for those June 9ths were going back to 1960 to try to determine what will this year's June 9th be? Or is it kind of an average of other temperatures? Like how would that actually work?
So it's going to be based on like the linear regression model, and we can spend some more time talking about it. I can show you some more afterward. That's okay?
Yeah.
Is there one more question before we?
So are y'all using
2 minutes.
these libraries at test level, or was this just like a personal?
This was a personal project, and I was curious. And actually, I meant to highlight the thank yous a little bit more. But if you're really interested in this stuff, there's a guy, oh my goodness, by the name of Andrew Kane. He's on Twitter, and he has a blog, and he's doing a lot more interesting stuff. Like, I just sort of stand in his light. And but like, if you're interested in like neural networks or computer vision and all that stuff, like he's kind of doing it. But we're not really using it at test level. I'm just trying to figure out if I could like learn enough and get enough useful stuff going to get Rubyists to kind of use it. And that's why I built the project, is because I'm like, well, if I build the project and people can see how easy it is, then people can kind of play with it. Yeah, so it's not a lot of code. It's just, yeah. Thank you.